Welcome back to Trick Equals Treat. Today, we're staring down a math problem that looks like it belongs in a haunted house. 4 square root of 3x cubed minus 13x squared plus 3 equals 0. Look at this equation. Look at it for 5 seconds. 1, 2, 3, 4, 5. That ugly square root of 3, it's the ultimate party crasher, designed to make you throw your hands up and reach for a calculator. But don't do it. We're going to solve this using pure brain power and 2 very different, very clever strategies. Our first approach is what I call the surgical strike. The secret to cracking this open lies in that stubborn middle term, negative 13x squared. 13 is a prime number, which usually makes factoring a nightmare. But watch this. We're going to perform a surgical split and turn that negative 13 into negative 12 and negative 1. Why 12 and 1? Because we're looking for hidden patterns. Also, for your homework consideration, would 9 and 4 also work? Now let's rewrite our equation. 4 square root of 3x cubed minus 12x squared minus x squared plus 3 equals 0. Now, let's group the first 2 terms and the last 2 terms. 4 square root of 3x cubed minus 12x squared minus x squared minus 3 equals 0. In our first group, we can pull out a square root of 3. And for the second group, keep your eyes on the prize. Remember, the number 3 is really just square root of 3 squared. That means x squared minus 3 is actually a perfect difference of squares. Let's write this down. 4 square root of 3x squared, x minus square root of 3, minus x squared minus square root of 3 squared equals 0. Factor the second group. X minus square root of 3, x plus square root of 3. Rewrite our equation. 4 square root of 3x squared, x minus square root of 3, minus x minus square root of 3, x plus square root of 3 equals 0. Bingo! Both parts of our equation now share a common factor. X minus square root of 3. We pull that out to the front. We get x minus square root of 3. 4 square root of 3x squared minus x plus square root of 3 equals 0. After a little algebraic cleanup, and we get x minus square root of 3. 4 square root of 3x squared minus x minus square root of 3 equals 0. Our first root is revealed. X equals square root of 3. For the remaining quadratic, 4 square root of 3x squared minus x minus square root of 3 equals 0. We can use cross multiplication. 4x plus square root of 3. Square root of 3x minus 1 equals 0. Look at this. Or we can use a quick quadratic formula to finish the job. And just like that, we have all 3 roots. X equals square root of 3. X equals negative square root of 3 over 4. X equals square root of 3 over 3. Now maybe you didn't spot that clever split. I mean, that's a tough one to spot in the wild. That's okay. For our second act, we're going to use the transformation. If you hate those messy radicals, let's just make them vanish. We're going to create a new variable, y, and we're going to say that our original variable, x, is equal to square root of 3y. Now let's rewrite the whole equation, but with y instead of x. Let x equals square root of 3y. We get 4 square root of 3 square root of 3 y cubed minus 13 square root of 3 y squared plus 3 equals 0. When we expand the terms, the radicals completely cancel each other out. Suddenly, our scary surds are gone, replaced by nice, clean integers. 36y cubed minus 39y squared plus 3 equals 0. We can make it even cleaner by dividing everything by 3. 12y cubed minus 13y squared plus 1 equals 0. If you look at the coefficients, 12 minus 13 plus 1, they sum to 0. Okay, and now for a fantastic little pro tip. For any polynomial, if all the coefficients add up to 0, then you are absolutely guaranteed that one of the roots is 1. That gives us a huge head start. Knowing that, we can factor out y minus 1 easily. We get this. Y minus 1. 12y squared minus y minus 1 equals 0. Moving on, we get y minus 1, 4y plus 1, 3y minus 1 equals 0. So our values for y are 1, negative 1 over 4, and 1 over 3. But wait, the problem asked for x, not y. Multiply these y values back by square root of 3, and we arrive at the exact same solution set we found earlier. X equals square root of 3. X equals negative square root of 3 over 4. X equals square root of 3 over 3. 2 methods, 1 result. The surgical precision of factoring, or the vanishing act of transformation. Which one would you use in a math competition? Let us know in the comments below. If you enjoyed this treat, don't forget to like, subscribe, and share. See you next time. Trick equals treat.